So we are now in the gas room and we're gonna open the N2 gas for the DSC analysis. It's the same as the TJ process. You should turn this into a counterclockwise direction. And then, as the same, you should turn the scale so that it reaches the black label. So after you turn the gas valve on, now you need to change the ball meter so that it goes between 20 to 30 cc. After this process, now you should turn on this isotherm container and turn it on and wait until this becomes 10 out of 10. Once that's over, now you should turn on the power for the DSC device. You can see there's this power, and when you turn it on, the green light goes on, like the TJ analyzer. Once the setting is over, now you can turn on the software for the DSC analysis. You should click this one. And the setting is over for now. So, in order to prepare the sample itself, you need the standard sample pan and the standard lid for USB press. So first, you use this pen set to move this into this weighing paper and also the lid. So the pan is in the left and the lid goes in the right. So after that, you move it to this weigher. And turn on the power and tar that weight to make it 0. Once the weight is set to 0, you need to put the powder into the sample pan, not the sample lid, and make the weight between 2 milligrams to 4 milligrams. So about 3 milligrams would be fine. Once the weight is set, you can now cap the lid on the pan and compress it using this compressor. And you shouldn't put the lid in this direction. You should top the lid in this, making the inside go up like this. And gently push it down like this and put it into this compressor. If you push this down, you can insert it into this hole, and then you push this bulb and compress it. Once it's complete, now you can turn it back out, and now the sample is prepared. So this is the place where you will insert the sample. Once you open this lid, there will be another cap. You will use the pencil to pull out the cap, and there will be another one. And once you pull it out, there is these two places. The left, the sample goes on the left, whereas the reference goes to the right. So this is the sample that I prepared earlier, this one. So I'll insert the sample into the left part. And the reference is just an empty lid capped on top of the empty pan. So you can find the reference in this cabinet, in here, and you can just pull it out and insert it on the right part. And then you put the caps that you removed earlier on top of it and seal the container. So now you have to manually change the program setting, the parameter setting. The starting temperature should be higher than the status, so for me I'll do it for about 40 degrees. And the ending temperature, it differs in the case of different materials, but in my case I'll do 30 degrees, 300 degrees. And the heating rate, it should be between 10 to 20, but the lower, the more accurate it becomes, so I'll make it 10. And the sample weight, you should insert the mass that you measured on the weighing machine. So for me, it was 3.82 milligrams. So I'll write 3.82 and I'll click start the experiment. And I'll just set up a new file. Click save, and it will start. Oh, and there's one thing. The final graph should be the temperature versus the milliwatt. So in order to change the x-axis from time to temperature, you should click the real-time plot. And then change the plot x-axis value from time to temperature. And when you click apply changes, then the x-plot changes to temperature. So you can see that the graph is being drawn like this, and you can find out several information based on this graph. So look at this peak. So when the peak goes down, it means it's an endothermal reaction. So the substance absorbs the heat, so that's why the heat on the surroundings goes down. And on the other case, when it's an exothermal reaction, the graph peak goes up. So you can know what's endothermal, exothermal, based on this type of graph. So this is the graph result of the DSC I measured earlier. The polymer is the zinc tartaric and the manganese tartaric, which is red and blue, whereas the monomer is the tartaric acid, which is black.